So let's think about the details of these transfers. Authority. Now, how does Sue establish authority? So that she can receive that, so that when Bob wants to give her the car, and she can actually prove that she has money that she can transfer to him. Right? How does that work? Well, the way it works is that she has the authority by showing that she can transfer a particular item with a signature. So she has something referred to as a private key with which she can sign a transaction, and Bob can check whether that transaction is actually is legitimate, so that he knows that Sue has the authority over a particular item. This is a more complicated concept, and if you're interested in the details of that, you have to take my decentralized finance class. The point here is merely that Sue has the ability to sign a transaction, and that she can prove that she is the signature therefore proves that she is actually the owner of that item. So even if that is the case, then the transaction actually is occurred. And now, can anybody break this, or can anybody, fake her transaction? Well, the idea is under cryptography, this is extremely difficult to do, and the assumption is usually it's impossible to do without actually having access to the private keys of Sue. Again, this is a little squishy, but for now, let's go with the assumption that this is unhackable as such. Right? So now, next about the execution. What is critical here is that when Sue sends money to Bob, so that Bob can transfer the car to Sue, and that the transaction actually has occurred, it has to be necessary that Sue cannot go to Charles at the bottom here and do the same transaction, buy another car, and spend the same dollar that she has twice, so that she can have two transactions. Now, this is referred to commonly as the double spending problem. Right? So when you have digital, now take a step back. When you think of the internet as the internet of information, I can send you a piece of information like a PDF file. Now, I'm not sending you the original PDF, so to speak. What I'm sending you is a copy of the PDF. If we think about money, of course, that's not going to work. So if I want to send you money, I can't send the same money to somebody else, because I can't send the copy of that money. That would be, forgery. Or let's put it differently. The world simply wouldn't work like that, because then the item that I receive will have the money that I receive, or that the other party receives from me, has no value. Right? So we need to be able that the sale happened, and that the dollars have been spent only once. And then finally, there's the question of the execution. We need to trust that the execution has actually occurred. Now, let me explain to you how the execution actually works in the blockchain. So Sue has access to money that is stored on her account. On a blockchain, it is stored, in fact, under something called a public key or an address, sometimes also a wallet. This is all a wallet address, a public key, this is all the same thing. Right? So essentially it means the information that the money is stored under a certain identifier. Now what Sue then does is she digitally signs a transaction using a private key, and then sends the information over in such a way that a network of computers can verify that she is indeed the owner, and that the signature that she provides is legitimate. Now, once that has been verified, these transactions are these verified transactions are put into a pool of transactions to be processed. Now, the processing works as follows. There's a group of entities referred to as miners. And what they do is they try to solve a cryptographic puzzle. Now, a cryptographic puzzle, in a sense, is to solve a cryptographic puzzle requires them to use computing power. To be very clear, this puzzle cannot be solved analytically. It can only be solved by doing random guesses. And the more random guesses you can do per second, the more likely it is that you eventually are successful in finding the solution to the particular puzzle that you aim to solve in order to, that you're trying to solve. And so that basically means that you, put a large number of random guesses through using simple, computer algorithms. Now, eventually one of these parties wins. You can see there's a little dot there, right? So that party has solved the cryptographic puzzle. And with that, the person obtains the right to take all these transactions and process them. And processing means that the person or the entity, this miner, puts them into what's referred to as a block. So they stack them nicely up Think about it as, like a file that you create where all these transactions are listed, and then these blocks are then added to the blockchain, right? So that basically means that this set of transactions has been processed. And in return, the miner receives some fees, which are paid for by the Zeus of this world as compensation. You can talk about the details of what these fees are there for and what they mean. This is actually quite important in the decentralized finance class. There's also a system intrinsic reward that the miner receives. You may have heard about this in Bitcoin. This is the Coinbase reward. Bottom line is the miner receives the reward for solving this puzzle. The information gets added to the blockchain, and then we go from there. Now, the next step we have to talk about is the security. So that is the question of this blockchain this is a set of transactions. We have to make sure that these transactions are secured in the sense of that they are mutable. Now, as I said already, a block consists of a set of transactions, and there are several blocks that are chained together. So let me explain to you how the chaining together works. The critical component is that every block has information about the previous block. Now, what that means essentially is that the block here, I hope I'm getting my hands right here, but the block here, the second block, at its top, contains information that is essentially a digest relating to the block that happens before. Formally, what that is just takes all the transaction and it's hashed together. Again, I can explain the details, and I will explain the details in a minute. But the point is that that's a digest. And if you were to change any detail in the first block, so for instance, saying that a transaction didn't happen, right? That would mean that the digest of this block, which relates to all the information that's contained in this block, would change. And that would mean that the link in the next block is wrong. So these two, the digest that this block, the second block refers to, is different from the digest that relates to the block itself, right? And so if such a change were to occur, if somebody tries to manipulate the blockchain, the network as a whole would immediately see the discrepancy between the digest of the second and the first block, and therefore reject whatever change has been proposed in the database. And in this way, these blocks are chained together. And when I say it can't be changed, this is a difficult process. We have to discuss exactly how that is happening. But for now, let's take the assumption that this linking of the digests provides the security.